Question 1a, calculate each of the following. So part 1, we're doing 3 multiplied by 400. I'm going to do 3 multiplied by 4, which is 12. And then the 400, the 2 zeros, is this multiplied by 100, which is 1,200. Part 2, 600 divided by 1,000. I'm going to write this as a fraction, and then I'm going to simplify. So I can divide top and bottom by 10. I can divide top and bottom by 10 again, which leaves me as 6 over 10. It doesn't tell me to write it as a fraction, decimal, etc. So I'm going to leave that as my answer. Part 3, 10 add 4 multiplied by 3. This is where you need to consider order of operations, guys. So you might have been taught BIDMAS or BODMAS, but I know from this one we've got addition and multiplication. Multiplication must come before addition, so I'm going to carry out that multiplication there first. So 4 multiplied by 3 is 12, so I'm actually doing 10 plus 12, which is 22. Next question, part 4, 6 subtract negative 7. Now they've put negative 7 in a bracket for here, which is for us here, which is very nice of them, but we need to recognise that double symbol. So we're subtracting a negative, so this double negative here becomes positive, so we're going to do 6 plus 7, which is 13. Part B, part 1, we're going to write 11 over 25 as a percentage. Now, a percentage is out of 100. So I'm going to make my fraction have a denominator of 100. So I'm going to convert it to an equivalent fraction. Well, 100 divided by 25 is 4. So if I multiply this fraction by 4, the denominator becomes 100. I have to do the same to the numerator. 11 times 4 is 44. A percentage is out of 100, so it must be 44%. Part 2, write 87% as a decimal. So when we're writing a fraction as a decimal, we're going to divide by 100. Okay, so we're going to do 87 divided by 100. You can actually write that as 87 over 100 and recognise that that's 0.87 as a decimal. And then part C, write down the value of root 49, so the square root of 49. So the square root of 49 is 7, because 7 times 7 is 49, and 49 is that square number here. When we square root a square number, we get the number that we multiplied by itself to get that value. Question 2a, circle one term from the box that matches the probability shown by arrow A on the probability scale. So these are our words in our box. We have impossible, unlikely, an even chance, likely and certain. Okay, and then we've got our probability scale that goes from 0 to 1. This is our halfway point. So from 0 to 1, this would be 0.5. This is our even chance. Okay, so we're not going to select even chance there. 0 would be impossible. So it's not impossible, it's not an even chance. If it was unlikely, it would be between 0 and 0.5. It would be between impossible and even. So we're not going to circle that. So it's either likely or certain. Now, if something's certain to happen, that has a probability of 1. 100% definitely going to happen. A isn't here, so it must be likely. Part B, the diagram shows a fair spinner. So this is our spinner, 1, 2, 3, 4, 5, 6 possible sections it can land on. Carol spins the spinner once. On the probability scale below, mark with an arrow the probability that Carol spins a number greater than 13. Okay, so let's see what our probability scale is sectioned into for equal parts. So we've got 1, 2, 3, 4, 5, 6 equal parts, which is handy because we've got 1, 2, 3, 4, 5, 6 sections that have an equal chance of being landed on. So we want a number greater than 13. Well, there are no numbers greater than 13 on this spinner, so the probability that Carol spins a number greater than 13 is 0. It's impossible. It can't happen on that spinner. So part 2, an even number. So we're going to mark with an arrow the probability that Carol lands on an even number using this spinner. So we need to see how many even numbers we have. So 2 and 8. The rest of those numbers are odd. So 2 out of those 6 sections are even, okay? So we have a 2 out of 6 probability of it being even. Let's check our scale. So we've got 1, 2, 3, 4, 5, 6 equal parts. 2 of those for an even number. So 1, 2. So we're going to pop our arrow there. Question 3. Circle the smallest value. So we have a mixture of fractions and decimals here. So we either want them all to be fractions with the same denominator to compare them, or we want them all to be decimals so we can compare them. I'm going to convert 1/2 and 3/4 to decimals, and then I'm going to compare those numbers. So 1/2 is 0.5, 3/4 is 0.75. So I'm going to compare, I want the smallest possible value. So I have 0.5, 0.35, 0.315, 0.75, and I have 0.6. Okay, so I'm going to make all of my numbers the same number of decimal places to start off with, because that makes it easier for us to compare these numbers, guys. So we're going to compare, we're looking for the smallest. So all of them have 0 in the ones, the units column. So we're next going to look at the tenths column. So we're going to look at this column here. So we're going to look for the lowest value in this column where there are 2 of them here, guys. We have 0.3 and 0.3 here. Okay, so we're going to work with those 2. So one of these 2 is the smallest. So we compared the ones, we compared the tenths, we're now going to compare the hundredths, okay? 5 is bigger than 1, so this number here has more hundredths than this one, so this one is bigger. So 0.315 is the smallest value. Part B, work out the following: 80 add 25% of 48 and then subtract 2/5 of 45. And we must show all of our working out. So what we need to do is evaluate these 2 things so that when we can do that sum of adding to 80 and then subtracting. So 25% of 48. Well, 25% is 1/4. So I'm going to half 48, because that's 50%. So 48 divided by 2 is 24. And then if I half 50%, I get 25%. So that 24 divided by 2 is 12. So I've got 80 plus 12. I've just worked out that 25% of 48. And then I'm going to subtract, but I'm going to subtract 2/5 of 45, okay? So here I'm going to work out 2/5 of 45. So when I'm working out a fraction of amount, we split it, divide by the denominator, and then we multiply by the numerator. So 45 divided by 5 is 9. That 9 multiplied by the numerator is 2. So 9 multiplied by 2 is 18. So we are doing 80 plus 12, and then we're subtracting 18. 80 plus 12 is 92. So then we're doing 92 subtract 18. You can do this however you want to, guys. I'm going to do it in a column method. So 12 subtract 8 is 4. 8 subtract 1 is 7. So the value is 74. Question 4. Miss Watkins picks a team of 1 girl and 1 boy to take part in a competition. She chooses the team from these students. So we have our girls Poppy, Ruby, Sally and Zoe. And we have our boys Tariq and Will. So part A, complete the list to show the different options that Miss Watkins has. The first 2 have been completed for you. And it does tell us here we may not need all of these lines, so we don't have to worry about trying to fill it all if that doesn't happen naturally. So the first pairing they've done for us is Poppy for the girls, Tariq for the boys, and then Poppy for the girls and Will for the boys. So Poppy's been dealt with, so let's get rid of Poppy. We're now going to do the same combinations but for Ruby. So we could pick Ruby and then Tariq, or we could pick Ruby and then Will. So that's Ruby that's been dealt with. The next option is she could pick Sally with Tariq or Sally with Will, and that's Sally dealt with. And then she could pick Zoe with Tariq or Zoe with Will. So we've dealt with all the possible combinations with each of those girls and each of those boys. Part B. Miss Watkins is equally likely to choose any of the possible options. What is the probability that she chooses Sally and Tariq? So she's equally likely to choose any of these. So we have 1, 2, 3, 4, 5, 6, 7, 8 possible options of pairs. So we've got 8 in total, but we're only interested in those that choose Sally and Tariq. Well, that only happens once here, look. So that's 1 out of those 8 possible combinations is our probability. Question 5. So we have a grid and we have some points marked and lines drawn. So it says here the diagram shows part of a kite. So part of a kite, A, B, C, D, and we've already got A, B and C, it's just D that's missing. It's drawn on a 1 centimetre square grid. Part A asks us to write down the coordinates of point B. Okay, so the coordinates of point B, well, this is point B, and when we're reading coordinates, we do our X coordinate and then our Y coordinate. So point B is -2 on the X and then +5 on the Y. Okay, part B, A, B, C, D has 1 line of symmetry. The length of BD is 6 centimetres. Mark the position of point D on the grid and measure the length of CD. So we've got to mark where D is and measure the length of CD. So this is a kite. So D is going to be directly below B, but they tell us specifically it's 6 centimetres. Now this is a centimetre grid. So we've got 1, 2, 3, 4, 5, 6. So D is here, look. And then if we complete the kite, just to be sure that it looks like a kite, I'm using a pen, guys. You guys need to use pencil just in case you need to rub something out so it's nice and clear for your examiner. So we've marked our position D, but they want us to measure the length of CD, which is the side that joins the points C and D together. So we're going to put our ruler on. We're going to start 0 at one of the points. So I'm going to start at C. And then I'm going to measure across. I get that at 4.9. So I'm going to put 4.9 centimetres. If you were doing this alongside me and you got slightly different, don't panic. There's usually a range that you can be within to get the correct marks for this question. Question 6. A grill is large enough to cook 20 kebabs. The following formula is used to calculate the amount of time in minutes it takes to prepare and cook kebabs on this grill. So that we've got the time equals 2.5 multiplied by the number of kebabs and then add 16. Part A, how long does it take to prepare and cook 10 kebabs? So that formula that they've given us, look, is to prepare and cook. So we're going to substitute 10 into this formula for our number of kebabs. So the time equals 2.5 multiplied by our number of kebabs and then add 16. Remember of order of operations, guys, we need to do that multiplication before the addition. 2.5 times 10 is 25. Add 16. 25 plus 16, well, 20 plus 10 is 30. That would be 35, and then add the 6, that would be 41. So it takes 41 minutes. Part B. How many kebabs can be prepared and cooked in 26 minutes? So this time we know our time is 26 minutes, but we don't know our number of kebabs. So it would be 2.5 multiplied by our number of kebabs, and then we would add 16, okay? So we're going to solve this equation because this is 26 equals 2.5k plus 16. So the first thing we're going to do is subtract 16 from both sides to eliminate it here and get the k term on its own. So when I subtract 16 from the left hand side, 26 subtract 16 gives me 10. When I subtract 16 from the right hand side, it cancels out the plus 16 and leaves me with 2.5k. Now I'm going to divide by 2.5. This is 2.5 multiplied by k. So if I divide by 2.5, 10 divided by 2.5 is 4. 2.5k divided by 2.5 is just k. So 4 kebabs can be prepared in 26 minutes. Question 7a. In 2019, the cost of a train journey was £300. In 1979, the cost of the same train journey was 8% of the cost in 2009. How much did the journey cost in 1979? So we need to find 8% of 300. Now I'm going to build this up. I'm going to find 5%, 1%, 1% and 1%. Because when I add those all together, that gives me 8%. So to find 5% of 300, I'm going to divide it by 10, because that finds 10%. So 300 divided by 10 is 30. That's 10%, but I only want 5%, so I'm going to half that. So 30 divided by 2 is 15. So 15 is 5% of 300. Now I want 1%. Well, 300 divided by 100 would give me 1%, which is 3. So all of these 1% are going to be the same. So I want 15 plus 3 plus 3. So 15 plus 9, which is £24. Okay, part B. So we've got information about a Saver rail card here. So an adult ticket gets 1/3 off. A child ticket gets 60% off. Now we need to pay attention to this asterisk. This asterisk means look at the sentence here. So this discount is off the normal ticket price only. So Bob has a Saver rail card and he's going to take his 7-year-old grandson on a journey by train. So for this journey, the normal price of an adult ticket is £15 and a child ticket is £8. How much does Bob save in total when buying 2 tickets using his rail card? Okay, so we're going to work out the discount that he gets for each of those tickets. All right, so an adult ticket is £15, but he gets 1/3 off. So we're going to find 1/3 of 15. So 15 divided by 3, we divide by the denominator times by the numerator, is 5. So he gets £5 off an adult ticket. And then we're going to deal with the child ticket. So a child ticket is £8, but he gets 60% off. So I'm going to find 50% of that and 10% of that. Well, 50% is half. So 8 divided by 2 is £4. 10% is 8 divided by 10, which is 0.8. So he saves £4.80 on a child's card. So how much is he saving total? 5 plus £4.80, which is £9.80. Question 8. Rasheen works in a restaurant. Part A. On a weekday, her pay rate is £9 per hour. One Monday, Rasheen worked for 6.5 hours. How much did Rasheen earn for this day's work? So 6.5 hours at £9 per hour. So we're doing 6.5 multiplied by 9. Now I don't like to work with decimals, so I'm going to multiply 6.5 by 10. So I'm doing 65 multiplied by 9. So 65 multiplied by 9, 9 multiplied by 5, 45, 9 multiplied by 6, 54. 54, add the 4 is 58. So this is 585, but I multiply by 10 to make 6.5. An integer that I could work with nicely, so I need to reverse that because it's a multiplication, so I'm going to divide by 10. So £58.50 is how much she earned. Part B. At the weekend, Rasheen's pay rate is higher. One weekend she worked for 14 hours. She earned a total of £314, which included £160 in tips. What is Rasheen's pay rate per hour at the weekend? Okay, so let's see how much she earned wages. So we're going to subtract the tips that she got from the total amount of money. So we're going to do 314 subtract 160. 4 subtract 0. 4, 1 subtract 6. We can't do that and get a positive answer, so let's borrow. 11 subtract 6 is 5. 2 subtract 1 is 1. So there was £154 in wages, and that was for 14 hours. So we're going to do 154 divided by 14. So 14, 28, 42. I'm just listing my times tables just in case I need them. So 14's into 15, well that's 1 remainder 1. 14's into 14 is 1. So that's 154 divided by 14 is 11. Okay, so she earned £11 per hour at weekends. Question 9. Thomas sells small boxes of 6 eggs or large boxes of 10 eggs. He sells X small boxes and he sells 8 more of the large boxes than the small boxes. So part A, write an expression in terms of X for the number of large boxes that he sells. Okay. So if he sells X small boxes, but then 8 more of the large boxes and the small boxes, he sells X add 8. So we're going to write X add 8 as our expression there. Part B, write an expression in terms of X for the total number of eggs he sells. Give your answer in simplest form. Okay, so total number of eggs he sells. Okay, so those X small boxes have 6 eggs in each. So we have 6 times X from our small boxes. But then those large boxes have 10 eggs. So we're going to have to add this expression, but multiplied by how many eggs are in each of those boxes. So we have 6x. I'm going to expand this bracket here. 10 multiplied by x is 10x. 10 multiplied by positive 8 is positive 80. And then we're going to collect like terms, okay? So we can put these x terms together. So 6x add 10x is 16x in total, and we've still got the add 80 there as well. Question 10. Work out the value of 2 to the power of 3 divided by 6 squared. Give your answer as a fraction in its simplest form. So it's already written as a fraction, guys. So I'm going to evaluate the numerator and the denominator and then write them as a fraction. So the numerator is 2 to the power of 3, which is 2 times 2 times 2. 2 times 2 is 4, times 2 again is 8. So I'm going to put 8 on the top of the fraction. Now I need to work out 6 squared, which is 6 times 6, which is 36. So 36 on the bottom, but we need it in our simplest form. 8 and 36, I know both of those are in the 4 times table, so I'm going to divide by 4. 8 divided by 4 is 2, 36 divided by 4 is 9. So I believe that that is the value in its simplest form. Question 11a. There are 5 children in the Cook family. 2 of the children are the same age. The other children are different ages. The range of their ages is 5 years. The mode of their ages is 14 years. And the youngest child is 12 years old. Find one possible solution for the ages of the other 4 children. Okay, so if the youngest child is 12 years old, that's already written here. Okay, we're going to deal with the range first. So the range is the difference between the biggest and the smallest. So it's the difference between the youngest child and the oldest child. So the difference between them is 5. So the oldest child is the age of the youngest child, which is 12, add 5. So the oldest child is 17. So I'm going to put 17 here as the oldest child. So the mode of their ages is 14. So the mode is the most common. So the age 14 is the most common age of these 5 children. Okay, 2 of the children are the same age. The rest are different ages. Okay, so if the rest are different ages, each of those 3 that have different ages won't be the mode, because they will all be different numbers and the mode is the same number. So 2 children of the same age. So we're going to do 2 at 14. And then we want a possible age for the fourth child that we've not mentioned yet. So these are in order. So as long as it's between 12 and 14, so I'm going to say that they are 13. Now there's more than one possible way you can do this. Okay, you might have also done 12, 14, 14, 15, 17 or whatever. But that's the way I'm going to go with this one. 11b. Mr. Cook takes his children out for lunch. The list below shows the food they ordered. So this is everything that they've ordered. When he pays the bill, he uses this special offer. So you get any 4 burgers and you get the 2 cheapest 3. So buy any 4, get the 2 cheapest 3. Estimate the total amount of Mr. Cook's bill. Give your answer correct to the nearest pound and you have to show all of your working out. So the key thing here is it says estimate. So the first thing I'm going to do is I'm going to round all of these things to one significant figure. So 1 mega burger would be £9, 1 vegan burger would be £7, a chicken burger would be £9, a regular burger would be £6, a fish pie would be £10, and the vegetarian lasagna would be £7. We're estimating so we can round everything to give us numbers that we would deal with the most. So they buy any 4 burgers, they get the 2 cheapest 3. Okay. So the 2 cheapest burgers are the regular burger and the vegan burger. So if they were to buy 4 burgers, they're going to get the cheapest 2 free. So they are the cheapest 2. So they're the ones that they wouldn't have to pay for. So we can estimate that Mr. Cook is going to have the price of a mega burger, so £9, plus the price of a chicken burger, £9. So he's paid for those 2 burgers. He's not paying for these because you buy any 4 burgers, 1, 2, 3, 4 burgers, get the 2 cheapest free. But he's also bought the fish pie and the vegetarian lasagna. So £10 plus £7. So that's 9 plus 9, that's £18. 10 plus 7, that's £17. So 18 plus 17, 20, £35 in total. Question 12a. The total cost of the gas for Reader used in 2019 was £432. To work out how much she should pay for gas each month in 2020, her energy company divided this amount by 12. How much did the energy company ask for Reader to pay for gas each month in 2020? So to calculate this, they worked out 432 divided by 12. So we're going to do that, 432 divided by 12. But to do this, I'm going to write out my 12 times tables, or some of them anyway. So I don't need to do them in my head more than once. So I'm going to start with 12s into 43. 1, 2, 3 gets us to 36. And the remainder from 36 to 43 is 7. And then we're doing 12s into 72. Well, I definitely haven't gone far enough here. So that would be 60. And then it would be 72. So that's 1, 2, 3, 4, 5, 6. No remainder. So they ask her to pay £36 per month. Part B. Mo is working out the cost of his electricity bill. His bill is for a period of 30 days. During these 30 days, he pays a fixed charge of 20 pence per day and uses a total of 500 kilowatt hours of electricity. Mo pays 14 pence for every kilowatt hour of electricity he uses. He pays VAT of 5% on the total of these costs. How much is Mo's electricity bill? Okay, so he pays a fixed charge of 20 pence per day. Okay, so that's 20 times 30. So 20 times 30, 2 times 3 is 6. So 20 times 30 must be 600. So that fixed charge, that one-off payment is 600 pence, which is £6. He uses 500 kilowatt hours of electricity and he pays 14 pence for every kilowatt hour of electricity. So we're going to do 14 times 500 for what he uses. Okay, Well, 14 times 5, I'm going to do that first. 5 times 4 is 20. 5 times 1, add the 2, 70. So 14 times 5 is 70. 14 times 500 must then be 7,000. Again, that's in pence, so that's £70 in total. We divide by 100 to go from pence to pounds. Okay, the last thing we need to figure out is he pays VAT of 5% on the total. So let's find this total. So the total he pays is £6 plus £70. So he pays £76 plus VAT of 5%. So VAT is value added tax. It's an amount that's added on to the cost of something. So we need to find 5% of 76 and then add that on. So 10% of 76 we divide by 10, which is £7.60. 5% is half of that, so £7.60 divided by 2, because 5 is half of 10. So half of £7 is £3.50. Half of that 60 pence is 30, so that is £3.80. So we're going to add that £3.80 to our total. So £76 plus £3.80. 0 plus 0, 0 plus 8, 6 plus 3, 7 plus 0. So the total cost of his bill is £79.80. Question 13. In a cafe, a half pint glass of lemon crush costs £1.50. So this half pint glass costs £1.50. A 500ml bottle costs £2. So this bottle costs £2. Oh, why did I write 20? £2. Show that the bottle of lemon crush is better value for money. And we've got a scale here that we can use to convert, guys. So we can use 1 pint is equal to 600 millilitres. So at the moment we've got millilitres and pints. We need them both to be in the same unit for us to be able to compare those values. So I'm going to convert half a pint into millilitres. Well, 1 pint is 600 millilitres, so half a pint must be half of that. 600 divided by 2 is 300, so that's 300 millilitres. Okay, now we're trying to show that this bottle is better value. So we're dealing with the glass and we're dealing with the bottle. Okay, so let's start with the glass first. What we want to do is make sure that we are comparing the price for the same amount on each bottle. Okay, so for 300 mils, so if we do pounds and mils, so 300 mils is £1.50. And then for the bottle, pounds and mils, 500 mils is £2. So what I'm going to do is I'm going to aim to get these both into the same amount. So these 300 mils and 500 mils are both multiples of 100. So let's figure out what each one would cost for 100 mils. And then we've got a comparable amount. So to go from 300 to 100, we would divide by 3. So we do the same on the other side of the proportion table. £1.50 divided by 3 is 50 pence, so 0.5 pounds. Okay, for the bottle, to go from 500 to 100, we need to scale down. We're going to divide by 5. I'm going to do the same on the other side. Remember, this is £2 divided by 5. Okay, so if you were to deal with this as pence, 200 divided by 5, so 200 pence divided by 5. 5s into 20 is 4, remainder, so that's 40, so it'd be 0.40 pounds, okay? So we're going to compare them now. For 100 mils, okay, a glass costs 0.5 pounds or 50 pence. For 100 mil, the bottle costs 0.4 pounds or 40 pence. So we can say here, therefore, the bottle is better value. You have to show those comparable amounts, guys. You can't just compare 300 mils and 500 mils. They need to be in the same units, and then you need to get the comparable amounts to check the prices. Question 14a. Theo invests £45,000. Jenny invests £35,000 in a new business. write the ratio of Theo's investment to Jenny's investment in its simplest form, okay? So what's important here is we write them in the order that this is written. So we're doing Theo's investment to Jenny's investment. So Theo's to Jenny's. Well, Theo invests £45,000. Jenny invests £35,000. We want it in its simplest form. So straight away I can divide both of these by 1,000 because of those 3 zeros on the end. So when I divide by 1,000, I get 45 to 35. And then I can divide them a little bit further. 45 and 35 are both in the 5 times tables because they end in a 5. 45 divided by 5 is 9. 35 divided by 5 is 7. So we divided by 1,000 and then we divided by 5. Part 2. At the end of the first year, Theo and Jenny shared the total profit made by the business in the ratio of their original investments. Jenny made £21,000 profit. What is the difference in the amount of profit made by Theo and Jenny? So straight away, we're sharing this profit in the ratio of their original investment. So we're doing Theo to Jenny in a ratio of 7 to 9. We're sharing the profit, guys. They tell us how much profit Jenny made. So Jenny's part of the ratio is actually worth £21,000, okay? We need to figure out how much Theo earned here in profit, and then we can see the difference between the two. So let's see how we scaled up this ratio for Jenny. We went from 7 to 21,000. Okay, so we need to figure out what we multiply 7 by. Well, 21 divided by 7 is 3, so that would be 3,000. So we've multiplied by 3,000. So let's do the same on the other side. So 3 times 9 is 27, but then we've also got that multiplied by 1,000. So Theo gets £27,000, Jenny gets £21,000. What's the difference? Well, £27,000 subtract £21,000. So 0, 0, 7 subtract 1 is 6, 2 subtract 2 is 0. So the difference is £6,000. Part B. The next year, the business makes a loss and Jenny decides to sell her share. She loses all of her profit from the first year plus 3/10 of her original investment. Calculate the amount of money Jenny loses. Okay, so first of all, she's definitely losing all of her profit, and they told us that the profit from the first year was £21,000. So she's definitely losing that £21,000. But she's also using 3/10 of her original investment. So let's go up here to part A. Jenny's original investment was £35,000. So she's losing 3/10 of that. So she's losing 3/10 of the £35,000. So we need to find 3/10 of £35,000. So we divide by the denominator. So we divide by 10, which is 3,500. And then we times by the numerator, so 3,500 times by 3. So 3,000 times by 3 is 9,000. 500 times by 3 is 1,500. When we total that, she loses another 10,500. So she loses the profit, which is £21,000, and 10,500. So if we add those together, in total, she loses £31,500. Question 15. Rearrange this formula to make n the subject. So we have t equals 5, add 3n. When we're rearranging, we're changing the subject. So instead of it being t equals, we want our final answer to be n equals. N is the subject. So we're going to do inverse operations like we would do when we're solving equations, but we're not going to get a numerical answer. We're going to get another formula at the end. So the first thing I'm going to do is I'm going to isolate the n term. So I'm going to isolate 3n so that I can end up with n on its own on one side of the equation. So the first thing I'm going to do is eliminate the 5. This is a positive 5. I know it's a positive 5 because there's no negative sign in front of it. So to eliminate positive 5, I need to subtract 5 from both sides. So when I subtract 5 from the left hand side, I've already got t there, but then I take away 5 from it. When I subtract 5 from the right hand side, it cancels out the positive 5 and leaves me with 3n. So now looking at this, I've got 3n, but I want n. So what I'm going to do, guys, is I need to eliminate the 3 in front of the n. 3n means 3 multiplied by n. So the opposite of multiplying by 3 would be to divide by 3. So when I divide the left-hand side by 3, it's everything on the left-hand side being divided by 3. So I already have t subtract 5. I'm going to write that all as a fraction over 3. When I divide the right-hand side by 3, 3n divided by 3 leaves me with n. And this is what I was aiming for, n to be the subject. So n equals t subtract 5 all over 3. Question 16. The diagram shows a ship's journey from P to Q to R. So P to Q to R. So this is the journey the ship has taken. The diagram's not drawn to scale, so that tells us that we can't measure anything directly from it. The ship travels on a bearing of 100 degrees for 8 kilometres from P to Q. So from P to Q, 8 kilometres, and it's a bearing from north of 100 degrees, and that's marked on the diagram for us. It then travels on a bearing of 160 degrees for 8 kilometres from Q to R. So we're going from Q to R, 8 kilometres, measuring from north on 160 degree bearing. So that's all labelled on the diagram for us. Part A, explain why the angle X is 100 degrees. So this angle here, guys, we're explaining why that angle X is 100 degrees. Okay, so what we need to recognise about bearings and those north lines, so these two north lines here, guys, point directly to north, they are parallel. So they are parallel lines, and what we have here, if we take this 8 kilometre distance, we have a transversal that's cut these two parallel lines. So we're going to use angles in parallel lines here. A couple of ways you can do this. The easiest way is knowing that this angle and this angle are equal. And they are equal because they are alternate angles. So we're going to simply write, we're explaining why angle X is 100. Well, the north lines are parallel lines. So I'm going to put alternate angles between parallel lines are equal. There we go. And then it says, part B, work out the bearing of R from P. Give a reason for each step of your answer, okay? So we're working at the bearing of R, but from P. So what we're aiming to get here is this whole angle here. So we're starting at P, from P, measure clockwise from north to the point R. So we're looking at this line, this dashed line that joins them. So we want this full angle here, guys, okay? So there's a couple of different ways we can do this. So I'm going to start by working with angles on a straight line. Okay, so if we have this angle here of 160 and then this angle here, so angles on a straight line must add to 180. Okay, so the angle here must be 180. So we've got 160, so this must be 20. We know this is 100 from part A. So I'm going to write angles on a straight line add to 180 degrees. Okay, that's my first reason, and I've been marking things on the diagram, which is absolutely fine. So we want the bearing of, so we're trying to find this angle here. So we've got this interior angle here of 120 degrees. Okay. Now we're going to work with the other two angles inside this triangle that's been formed here. So this angle and this angle, okay? But what we need to note about this triangle that's been formed is it's an isosceles triangle, guys. So we've got 8 kilometres and 8 kilometres. So that tells us that the base angles in this isosceles triangle are equal. So we're going to write here base angles in isosceles triangles are equal. So these are the base angles because they're at the bottom of those equal sides. So this is 100 plus 20, so that's 120. So I know angles in a triangle add to 180. So if that's 120, 180 subtract 120 is 60. These two are equal, so 60 divided by 2 is 30. So this is 30 degrees and this is 30 degrees, guys, okay? And I'm going to write my reason here. I used angles in a triangle then, didn't I? Angles in a triangle add to 180 degrees. So now I can work out the bearing of R from P. This full angle here, it's 100 plus 30. So bearing of R from P is 100 plus 30, which is 130 degrees. Now what's really important here, guys, is when you're giving bearings, they have to be free figures. So if that was less than 100 degrees, we'd have to put a 0 in the front, but it isn't. We've got 1, 2, 3 figures, so that works for us. Question 17a. Brad is a landscape gardener. One working day, he spends 3/7 of his time designing a garden, 5/14 of his time digging, and the rest of his time buying plants. What fraction of his working day does Brad spend buying plants? So this is one working day. So he spends 3/7 of that one day designing it, 5/14 of that one day digging it, and the rest of the time buying plants. So if we subtract these two fractions from 1, so 1 subtract 3/7 subtract 5/14, that is going to tell us what fraction of his working day he spends buying plants. So to be able to subtract these, I need them all to be over the same denominator. So we've got 7 and 14. Well, 14 is a multiple of 7, so I'm going to multiply this fraction by 2. So that makes it a fraction over 14. I'm going to write this as a fraction over 14, which would be 14 over 14. So we have 14, subtract 6, which is 8, subtract 5, which is 3. So it's 3/14 of his day buying plants. Part B. Arun is an architect. One working day, he spends 324 minutes of his time on paperwork. This is 3/5 of his working day. For how many hours does Arun work on this day? So 324 minutes is equal to 3/5 of his day, okay? So I'm going to find out what 1/5 of his day would be. So 1/5 of his day would be dividing this by 3, okay? So 324 divided by 3. 3's into 32 is 10, remainder 2. 3's into 24 is 8. So 1/5 of his day is 108 minutes. So I want to find out how many hours he works on that day. So I want 5/5. So I'm going to multiply that by 5. So 100 times by 5 is 500. 8 times by 5 is 40. So it's 540 minutes. We want hours, guys. So I'm going to do 540 divided by 60. Couple of different ways you can do this. But I'm just going to count up in 60. So 60, 120, 180, 240, 300, 360. 420, 480, 540. Counted up in 60s because there are 60 minutes in an hour. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 hours worked that day. Question 18a. 20 teenage boys take part in sprint races over 100 metres. So 20 teenage boys over 100 metres. One of the boys draws a graph to summarise their time. So we've got the 100 metre sprint time for boys. Here we've got the number of boys and we've got the time it takes them in seconds. Make one criticism of the diagrams. This is a 1 mark question. So one criticism of this diagram is that there are gaps between the bars because time is continuous, isn't it? It's a continuous measure. So the bars shouldn't have any gaps. So we're just going to put there are gaps between the bars. 18b. The bar chart shows the favourite holiday activity of a group of 30 students. So favourite activity, number of students, and then we've got beach sports, fun fair rides, water park and cycling. Use the bar chart to complete the pie chart opposite. So we've got a pie chart on this other page here. You may use the table to help you. You must show all your working out. So we are going to use that table to help us, guys. Okay, so we're doing this bar chart, but we need frequencies to start off with. Okay, so we want the frequency of beach sports. Well, beach sports goes all the way up to here. So that's 8, 10, so here must be 9. So we're going to put 9 for beach sports. Fun fair rides goes all the way up to 12. Water park up to 4. And then cycling up to 5. Now that we have our frequencies, we don't need this bar chart anymore, so we can just deal with our pie chart. So now we need to work out the angles that we're going to plot in this pie chart for each of these different activities. So we need to find out this total here. Now it did tell us at the start of a question that we were working with 30 students. So let's just check. 9 plus 12 is 21, plus 4 is 25, plus 5 is 30. So the total is 30. Now angles in a full circle is 360. So we're going to do 360 divided by 30. Well, let's do 36 divided by 3. Shall we, to start off with? So 36 divided by 3 is 12. So each one of these people is worth 12 degrees. So we're going to times everything by 12. So 9 times 12, or 9 times 10 is 90. 9 times 2 is 18. 90 plus 18 is 108 degrees. 12 times 12 is 144. 4 times 12 is 48, and 5 times 12. 5 times 10 is 50, 5 times 2 is 10, 50 plus 10 is 60. And just do a quick check. We want these to add to 360 degrees, so 108 plus 144, so that's 252, plus 48, that's 300, plus 60 is 360. Fantastic. We've got the angles now that we're going to draw into our pie chart. So to draw the angles on our pie chart, we're going to need a protractor and we're going to need a pencil. I'm using a mechanical pencil here. I promise you it's a pencil. But a pencil is important because if you make a mistake, you want to be able to rub it out so that you can redo with the correct drawing over the top. So we're going to plot these angles onto this pie chart, and we've already got a line drawn here. That's the line that we're going to start from, guys. So the centre of our protractor here is going to go on that dot at the centre of the pie chart, and then this line here, the 0 line, is going to lay flush with that line that's already drawn for us to give us our starting point, like that. So the first sector that I'm going to draw is the beach sport, so it's 108 degrees. So 0 is here, so I'm using the outer ring. So I'm going to go round, so I've got 100, 105, 6, 7, 8. So I'm going to mark a point there, and then I'm going to line it up with the centre, and I'm going to draw my sector. What's really important here is now that we label them. You can write beach sports in full, but they've put B, so I'm just going to put B for beach sports there. Okay, I've got an angle there nice and clear, but you can put your angle on there as well if you want to. It's really good for marks with the examiners that they see you've worked out the correct angles, even if everything goes a little bit wrong here. Okay, the next section we're going to draw is the fun fair rides. That's 144 degrees, but I now need to start from that line that I've just drawn. So I'm going to turn my paper around. I'm going to do exactly the same process. The centre of my protractor goes on the centre of the pie chart. This 0 line is going to lie flush with that line there. Good. We're doing 144 degrees for this sector, so we're going to go round 140, 1, 2, 3, 4, make a mark, and then join it up with the centre of the pie chart. So that was fun fair rides, that sector there. So I'm going to label that with an F, and I'm going to put, oh, break my pencil, 144 degrees there, just to make it nice and clear. The next sector that I'm going to draw is the water park. So the water park is 48 degrees. And again, I need to start this sector from the line I've just drawn. So I'm going to turn my pie chart around again. Centre of the protractor with the centre of the pie chart. The 0 line of the protractor flush with that line that you've just drawn. So you pop on the centre, flush. And then remember, this one is 48 degrees. So 10, 20, 30, 40, 45, 6, 7, 8. So make a mark and then join the centre of the pie chart up with that mark. So that sector there is the water park, and that was 48 degrees. So there's one sector left, okay, and that has to be cycling. I don't need to plot it. If I've plotted these angles accurately, then that should have left me with a 60-degree angle there, and that's for cycling. What's really important with pie charts for full marks, guys, you label the sectors of the pie chart that you've drawn. Examiner can see them nice and clearly, but you've also clearly shown the angles that you've calculated as well. Question 19. In 2019, €1 is equal to 0.9 pounds and $1.25 is equal to £1. In 2019 again, here's how the dates match. A silver pencil cost €110 in Germany. The same pencil cost $125 in the USA. In which country was the pencil cheaper? We're going to tick a box, but we've got to show all our working. So we're not actually going to tick a box, guys, until we've done some working out. So we have the pen, we have the cost in euros and the cost in dollars. We can't compare them directly at the minute because they're different currencies, different units. So we need them both to be the same unit. Now these conversion rates here take us from euros to pounds and from dollars to pounds. So we can convert euros to pounds and dollars to pounds. And once they're both in terms of pounds, we can compare the amount. So I'm going to give myself a little proportion table. If you've watched my other videos, you'll know that I enjoy using a proportion table. So we're going to start with the price in euros. So €1 and pounds. So €1 is equal to 0.90 pounds. Okay, we have 110 euros in Germany. So to get from 1 to 110, we would have scaled up. We would have multiplied by 110. So I need to do the same on this side. Now we're working on a non-calculator paper here, guys. So I'm going to do 0.9 times 110. So I'm going to times 0.9 by 10. So I'm doing 9 times 110. Well, 9 times 110, 9 times 100 is 900. 9 times the 10 is 90. So that's 990, okay? But I multiplied by 10. So now I need to divide by 10 because it's a multiplication. I need to reverse that. 990 divided by 10 is 99. So it would be £99 in Germany. So let's make a note that that's Germany. Okay, so now we're going to convert the USA's dollars into pounds. So we're going to use another proportion table. And we're going from dollars to pounds. So $1.25 is equal to £1. So we have $125. So to get from 1.25 to 125, we've scaled up and we would have multiplied by 100, because if you see 2 decimal places here, but we've got no decimal places here, so we would have multiplied by 100. So we need to do the same to the other side. So 1 multiplied by 100 is £100, and that is the USA. So now we're going to compare these prices, guys. In which country was it cheaper? Well, it's £99 in Germany, £100 in the USA. So Germany is cheaper by £1. So we're going to tick Germany for our answer. Question 20. The diagram shows a parallelogram ABCD and the diagonal AC. So ABCD is our parallelogram, and AC is the diagonal that goes from A to C. The diagram's not drawn to scale, so that means we can't measure anything directly from it. And it wants us to tick 2 correct statements. So we've got 1, 2, 3, 4, 5, 6 statements here, but only 2 of them are correct based on this diagram here. Now all of these statements are linking to angles, sides, etc. So I'm just going to start by labelling on the parallelogram what I know. So I know that this side and this side are equal. They're also parallel. This side and this side are equal. Also parallel. Okay, so let's have a look at this. Angle ABC is not equal to angle CDA. So when we're dealing with angle notation, that middle letter is at the point at which the angle occurs. So ABC, ABC. So they're saying that this angle is not equal to CDA, which is this angle. Well, they're opposite angles in a parallelogram. That is not true. Okay, so that's not a correct statement because they would be equal. Next one, AB equals DC. AB equals DC, that's correct. AD equals BC. AD equals BC, that's correct. And AC is a side of both triangle ABC and triangle CDA. So ABC, it's the longest side, and then CDA is the longest side. So that statement is true. Next one, triangle ABC is similar to triangle CDA with enlargement scale factor 0.5. So ABC is similar to CDA with an enlargement scale factor. So that means one of them would have changed size. Well, that's not the case, is it? So that's not a true statement. Next one, triangle ABC is congruent to triangle CDA. Congruent means the same, exactly the same, lengths, everything. That's correct there. Oh, so it's not congruent, sorry. Is congruent. So not congruent is false. Is congruent is true. And then the last one, let's double check. We've ticked 2, but let's just double check we're not going wrong somewhere. AB represents the shortest distance from B to AC. So AB is the shortest distance from B to AC. Well, that's not correct, is it? That's not how it works. So we've got our 2 statements ticked there. Question 21. The diagram shows a cone placed with its circular base on a table. So there's the base of the cone on the table. It has a base radius of 15 centimetres and a height of 30 centimetres. Work out the volume of this cone. Give your answer as a multiple of pi, which is handy because this is a non-calculator paper. Okay, volume of the cone. We need to do 1/3 multiplied by pi, multiplied by the radius squared, multiplied by the height. So let's substitute in what we know. So we have 1/3 multiplied by pi, multiplied by, we want the radius squared. So the radius squared would be 15 squared, multiplied by the height, which is 30. You're going to get your first mark, guys, for substituting in the values that you know to the formula for the volume of a cone. Now we're going to do a little bit of simplifying. So we've got 1/3 multiplied by pi. 15 squared is 225 times by 30. So I'm going to do 225 times by 30 over here. So 0 times 5, 0 times 2, 0 times 2. 0 placeholder because we're moving into the tens. 3 times 5 is 15. 3 times 2 is 6 plus 1 is 7. 3 times 2 is 6. Add those together. So we've got 1/3 multiplied by pi multiplied by 6,750. Okay, we've got 1/3 multiplied by this. I'm going to do 6,750 divided by 3. Somewhere 3, 6, 9, 12, 15, 18. So 3's into 6, 1, 2, no remainder. 3's into 7, 1, 2, remainder 1. 3's into 15, 1, 2, 3, 4, 5. Then that 0 is going to get carried up. So it's 2,250. So we have 2,250 times by pi. So that's 2,250 pi. Part B. On the 1 centimetre grid opposite, so we've got a 1 centimetre grid on our next page, make an accurate scale drawing of the plan and side elevation of this cone using the ratio actual cone to scale drawing is 5:1. So let's work with this ratio to start off with. The actual cone is 5 times bigger in real life than in the scale drawing. So let's figure out what our radius and height are going to be. So our scale drawing radius is going to be 15 divided by 5, which is 3 centimetres. And then our scale drawing height is 30 divided by 5, which is 6 centimetres. So we've got a radius of 3 centimetres and a height of 6 centimetres. And we're going to use that information to draw on this plan here. So I'm just going to actually write it up here. Radius equals 3 centimetres, height equals 6 centimetres, just to make my life a little bit easier. Okay, so we're going to start with the plan. So the plan is the view that you get of the shape when you're looking at it directly from above. Okay, so this is a cone. So if we were to look at the cone directly from above, we're going to see a circle. All right, a circle with radius 3 centimetres. So I'm going to take my ruler and a compass, and I'm going to measure 3 centimetres, and it doesn't matter where, but anywhere on here. And if you just double check, because sometimes copying of exam papers makes things a little bigger or smaller, change the size slightly. So it's 1, 2, 3, because it's a centimetre grid, and I'm going to draw that circle, guys. So that is the plan of the cone. That's what we would see if we were looking down onto the cone directly from above. Okay, the side elevation then, guys. So the side elevation would be what you see when you look from the side in this direction. Well, you'd see a triangle, wouldn't you? All right, and that triangle has a height, and the radius would be halfway across the base. So for this side elevation, the diameter is what we're interested in here, because that would be the base of the triangle. So that's 2 times the radius. So the diameter is 6. The height is 6, so we're actually working here with potentially an isosceles triangle. So what we need to do, the diameter is the base of our triangle. So we're going to go 1, 2, 3, 4, 5, 6. And then we want a height of 6. So we're going to go from the middle here, 1, 2, 3, 4, 5, 6. And that's where we're drawing our shape for the side elevation. Question 22. A tank contains 225 litres of water. A tap at the bottom is open so that water flows out at a constant rate of 5 litres every minute until the tank is empty. Part A. On the graph paper below, draw a line to show the volume of water in the tank at any time after the tap has been opened. So the key here is a line, so it's a constant rate of water flowing out of the tank. So we're going to have a straight line here, guys. But what we need to notice is that actually we don't have any scale here. Now, the tank starts with 225 litres of water. So we need our scale to go up to 225 litres. So let's have a think about how we could do that. So we've got 1, 2, 3, 4, 5, 6. Okay. So if we went 50, 100, 150, 200, 250, that would work. So you got 50, 100, 150, 200, 250. Okay, let's go with that. It doesn't matter that we've gone slightly over, but what helps with this scale here as well is from 0 to 50 is 10 little squares. 50 divided by 10 is 5. So each little square is worth 5. And actually, 5 litres of water every minute. So that really helps us out. So when the tank is full at the start, we've got 225 litres of water. Okay, so at 0, so times 0, 225 litres of water. That's where we're going to start, okay? And then we lose 5 litres every minute until the tank's empty. So if we get to 10 minutes, we've lost 5 minutes for every, we've lost 5 litres for every minute. 10 times 5 is 50. So we would go from 225 to 225 take away 50, which would be 175. And then for the next 10 minutes, if we go down another 50, we'd go to here. And then for the next 10 minutes, we'd be here. And then the next 10 minutes here, and so on. So we're going to take our ruler. Obviously, you'd be doing this in pencil, guys. I'm going to do pen just so you can see nice and clearly what I'm doing here. So I've marked on the points that follow the trend of this graph, and then I'm going to draw the line. Now we'd expect the line to go down because this tank is emptying, so it's starting up here and then it's emptying. Okay, so that's part A. We've drawn our graph. Part B, how many minutes does it take for the volume of water in the tank to decrease by 40% of the original volume? Okay, so we need to find out what 40% is. So the original volume is 225 litres. So we want 40% of 225. So we can find 10%. To find 10%, we divide by 10. So 225 divided by 10 is 22.5. I want 40%, so I can multiply my 10% by 4. So I'm doing 22.5 multiplied by 4. Well, 22 times 4, that's going to give me 88. 0.5 times 4 is going to give me 2. So that gives me 90. Yeah. So 90 is 40% of the volume. We're decreasing by 40%. So 225 take away 90. So that's 10, 100, 135. So we want to know how many minutes it takes for it to get to 135 litres. So let's figure this out. 150, 125, 130, 135. Remembering each little square is worth 5. So we're going to go along to our graph. When we meet our graph, we're going to read down and we're going to read off that time there. Again, you'd be doing this in pencil, guys. I'm doing it in pen so you can see it clearly over the grid. So we've got 10 to 20 is 10 squares. So each square is 1, 11, 12, 13, 14, 15, 16, 17, 18. So nice and clearly, I'm going to put 18 minutes and circle it so then I know that that is my answer. Question 23. The probability that Kathy cycles to work on Monday is 0.6. If she cycles to work on Monday, the probability that she cycles to work on Tuesday is 0.3. So if she cycles to work on Monday. If she does not cycle to work on Monday, the probability that she does not cycle to work on Tuesday is 0.1. Complete the tree diagram. Okay, so what's useful for us to hear? I know that seems for us here, so I know that seems a little bit confusing, but actually they've done us a solid because we've got at least one part of each of these branches filled out. Okay, so that's helpful to us, guys, because these branches have to add to 1 for probability. So the probability that she cycles to work on Monday is 0.6. So the probability that she doesn't cycle to work on Monday is 1 take away 0.6, which is 0.4. Okay. The probability that she cycles to work on Tuesday, if she cycled to work on Monday, is 0.3. Probability that she does not cycle is 1 take away 0.3, which is 0.7. Okay. So if she does not cycle on Monday, the probability that she cycles on Tuesday we need to fill in, but the probability that she doesn't cycle on Tuesday is 0.1. So 1 take away 0.1 is 0.9. So that completes that branch. They have to add to 1, guys. Part B, calculate the probability that Kathy cycles to work on both Monday and Tuesday. Okay, so when we're working with probabilities from a tree diagram and we're following a journey across a tree diagram, we're going to multiply, guys. So cycles to work Monday and Tuesday. So cycles on Monday is 0.6, cycles on Tuesday is 0.3, and we have to multiply those together. Okay, 0.6 multiplied by 0.3 is 0.18. If you weren't sure about that, let's multiply them both by 10. That's 6 times 3, which is 18, but then we'd have to reverse both of these multiplications. So we'd divide by 10 and divide by 10 again. So that's our answer. Part C. Calculate the probability that Kathy does not cycle to work on either day. So does not cycle Monday and does not cycle Tuesday. So does not cycle Monday, 0.4, and we've got the multiply. Does not cycle on Tuesday is 0.1. 0.4 times 0.1 is 0.04. Okay, 4 times 1 is 4, and I need 2 decimal places. Question 24. In a factory, 6 identical machines can make 3,000 erasers in 2 hours. How long would it take 8 of these machines to make 1,000 erasers? Okay, so if 6 machines make 3,000 erasers in 2 hours, then 6 machines make 3,000 divided by 2 erasers in 1 hour. Okay, so it's 1,500 erasers in 1 hour for 6 machines. We're going to divide that by 6. So we're going to see how many each machine makes. So one machine is 1,500 divided by 6. So let's figure that out. 1,500 divided by 6. 6 into 15 is 2, remainder 3. 6 into 30 is 5, so that's 250. So one machine makes 250 in 1 hour. Okay, so that's 250 in an hour. So how many machines is 1 hour? So 8 machines make 1,000 erasers. Well, if we times this by 8, 250 times 8, 8 times 200, 8 times 50. Okay, so that's 2,000 erasers in 1 hour for 8 machines. We're only looking for 1,000, which is half of that. So we're going to say it would take 30 minutes for 8 machines. (25a) Expand and simplify 4x add 5 multiplied by 2x subtract 1. I'm going to use a grid method here just to organise my work a little bit. You might use FOIL or another method. So my first bracket, 4x plus 5, and then 2x minus 1. So it's a multiplication. 4x multiplied by 2x. Well, 4 times 2 is 8. X times x is x squared. 4x multiplied by negative 1. Well, a positive multiplied by a negative is a negative. So that's negative 4x. 5 multiplied by 2x gives us 10x. And then 5 multiplied by negative 1. A positive multiplied by a negative gives me negative 5. So I have 8x squared, and what I'm going to do is I need to combine like terms. So this diagonal, these x terms need to be combined. So I have 10x subtract 4x. 10 subtract 4 is 6, so I'm left with positive 6x, and then I've got subtract 5 on the end. Part B, factorise. X squared subtract 10x add 21. So this is a quadratic here, so it's going to factorise into 2 brackets, and I know it factorises into 2 brackets because I have a squared term and then that constant number term on the end. So I'm going to put it into 2 brackets. Each bracket's going to have x because that's how I'm going to get my x squared. So now I need to look for 2 numbers that multiply to give me 21. So 1 and 21 and 3 and 7 are my options for pairs of numbers. But what I want to happen is when I multiply them, I get a positive answer, but then when I add them, I get negative 10. So the only way I'm going to get a positive answer is if both of these brackets are positive or if both of these brackets are negative. Now, if both of these brackets are positive, 3 plus 7 is positive 10. That's not going to work for me. So I need these brackets to be negative. So I've got negative 3 and negative 7. Okay, part 2. Use your answer to part B to write down the solutions of the equation x squared subtract 10x add 21 equals 0. So this is the quadratic that we worked with here, and what we've done here is we've factorised it. So that's the first step in solving by factorisation. Now if this quadratic equals 0, then we can say that x subtract 3, x subtract 7 is equal to 0. So for it to be equal to 0, these brackets being multiplied together, each bracket must equal 0 at some point. So if x minus 3 equals 0, we can solve that for x equals 3. If x minus 7 equals 0, we can solve that for x equals 7. And that's our solutions. Question 26. Vikram wanted to find out how many moths there were in a small woodland. One night, Vikram captured a random sample of 12 moths and marked them. He then released them back into the woodland. The next night, Vikram captured a second random sample of 30 moths. He found that 9 of these moths had been marked. Vikram estimated that there were 40 moths in the woodland. Show that Vikram's estimate of the number of moths was correct. So this is called capture-recapture, okay guys? So we need to be aware of this formula, m over n equals r over t. You may have seen it differently. This is the one that I use. So m is the total marked, okay? So the total marked in this first sample here, so 12. So there were 12 total marked. N is the total population. We don't know that. Vikram reckons that it was 40, but we don't know that yet. So N is the thing that we're looking for. R is those that are marked on the recapture. Okay, so on that second sample, 9 of the moths had been marked. And then T is equal to the total second sample. So it was 9 out of 30. So we're going to use this now to solve for n for that population. So what we would do is, if we multiply this equation by n, we have 12 equals 9n over 30. Then if we multiply by 30, 9n equals 12 times 30. So 9n equals 360. N equals 360 divided by 9, so n equals 40. So we've shown that his estimate is correct. Part B, comment on how reliable Vikram's estimate is likely to be. So we're going to say, let's look at these sample sizes, okay? 40 is the estimated population, but he captured a sample of 12. So actually his first sample was quite small compared to his second sample. So I'm going to say it may not be reliable as he only captured 12 moths in the first sample. So it may not be reliable. He only captured 12 moths in the first sample.